A quick update on my VGA card. I have made some minor adjustments and I'm getting a kind of a nice result out of this. I have now upgraded, if you want to say that, my video card to 16-bit color instead of 8-bit per pixel. So previously I was using 1 byte of color. I'm now using 2 bytes of color per pixel. So I've got 5 bits for red, 6 for green, and 5 for blue is how I'm using it. And what I did was I was over here following up from my last video where I have these multiplexers on the way out of my circuit into the VGA. And I had a pair of transceivers, and I was using those transceivers to flip between the low byte, high byte, and I really was trying to get rid of one layer of chips here just to help me with my overall propagation delay going through this system. Because I was noticing that when I was doing a video address A0, when it was high, I could tell the system wasn't quite getting that all the way through the system fast enough. And that would have been my fastest moving thing through the system. And it was struggling a little bit. I'm only running HC chips. I could probably put in ACs and get around that. But I don't have any on hand. And so I thought I will just come in here and see if I can get rid of those transceivers. And in the last video I had commented that probably one thing I could do is just go to 16-bit, and that way for 16-bit color I can just pull all of these colors directly out into a pair of 273s instead of just a single 273. So I've done that. I've put in the resistors that you're seeing, seeing right here, as far as what I have set up right here. So here's my pair of 273s coming out of the multiplexers here, and I see a wire that's creeping out. The pain of breadboards. And so now I basically will latch that color data, run it through these resistors as you see on the screen, which I know are not probably quite right, and I've got to do some work on that to clean those up, but this was just something that was quick and easy to set up here. The other thing I had to do is come over the actual counter that I'm using for my VGA. I had to shift everything by 1. So basically what was the lowest, the video address 0, I shifted up to be video address 1. And that means every time the pixel clock ticks, I'm jumping 2 addresses in memory. Which is good because I've got the low address and high address. So now I've updated my logic up here so that every time I go to read for video output, I turn on both of the memory chips simultaneously. One's got my high colors, one has my low colors, and every time the pixel clock ticks, it's shifting to the next 16 bits. It's always staying in those odds. So that's what I've changed. So a little bit of logic change here, very minor, just to make sure these were both enabled instead of toggling. Shifting these by 1 so that I'm now using A0 through A18 and my video addressing. And then if I'm doing 2 bytes per pixel, that means I now need to potentially use the full 1 megabyte if I'm going to do 800 by 600. For 640 by 480, I obviously don't need a full 1 megabyte, but I need, what, 600K maybe? So 600K of the 1 meg will be used out of each of these now to do the 2 bytes per pixel. So I'm going to go ahead and turn on the system. You can see here I've got the monitor off. I'm still running at the full 8 megahertz processor, 16 megahertz for all of this. And when it comes up, you get the snow, and then what I'm doing is I'm showing, instead of just filling with all black or all white the screen, I just loaded a bit into a register, and then for my color, I said for the segment that I'm going to fill, when I initialize it, start with that bit in the far right. So this is the lowest blue value. And then when I get to the next segment, I shift that bit over 1 to the left. So this is the next brightest blue, and then it just increments to the highest brightness of blue. And that's just a single bit. So if I turned on all 5 bits for blue, it would be brighter than this, of course. It'd be all of those voltages put together to get yet a brighter blue. And then I have my 6 greens, and then you can see 4 reds. You're not seeing the 5th one because that's into memory that isn't needed for what's visual or visible on the screen right now. And then now, of course, if I want to go down a line, I have to tell it to add 2048 because there's 2048 memory locations before I get to the next line. So I can do that. I can work my way through and address things. I can still press F12 and toggle between the two frames, which you can see the noise is different on the two frames, which to me, I'm going to attribute that to either the ICs or more likely the wiring, different length wires, grounding problems, whatever it might be. Something else I've done is I put in some initial, just messing around with, can I type? So hello world. And if I press enter, I'll go down a line. This is a test. And so you can see my typing is working. It's probably not perfect. I can flip between the frames and you can see that text is on both frames. So to make this work, when I hit a key, what I have to do is basically write it to a frame that's not going out to the VGA. So in other words, the frame that my 286 is controlling, I have to write that character to it. I swap the frame so that's now output, and then I have to rewrite it to the alternate frame that's not visible on the VGA. So every time I hit a key, I'm going through that process of swapping frames. And I don't know if the camera's picking it up, but I can tell that just by seeing the noise difference on those two frames. But now I can go through and basically type away, and that is all working reasonably well, other than just general noise and signal quality issues. But I think if I can get a PCB version of this, I can probably clean up all of that. That's my goal, at least. So at this point, I am probably getting pretty close to ordering a PCB version of this. See if I can get this drawn out on a two-layer board and order that up, just to see how much it does help out with the noise and some of this other stuff. And I've gotten good ideas from folks of other ways to be improving this, and I'll continue to work on that. But for now, this is giving me my as much memory as I really need to run this resolution. Or if I want to go to 800 by 600, I can do that. And it's just plain old static RAM, so it's not costly. I'll have to add up what the total bill of materials is on this, but other than these two P-socks, when I bought these, they were $15, and right now they're hard to find, and if you can find them, they're like over $100 US. So that's kind of sad right now, but hopefully those come back in stock at a lower price, back to the $15 type of price. And what I have in these for logic, I could probably fairly easily convert that to just discrete ICs. It's just a space thing and a flexibility. Like for what I did today to go to 16-bit color was a real quick PSOC update, and I didn't have to mess with any wiring. If it was a PCB, I could have done those same updates with this part of it at least, and this part of it, and not have had to physically change anything. The only physical change I made was with these ICs and the resistors and such down here. So that's where I'm at with this. I have more work to do, but I will work through that and see if I can get all my code updated so I can keep typing and have the typing go from segment to segment to segment in the frames and not get stuck. Just right now, the only thing I have up here is if I type something, it's going to cycle around in that segment. So you can't quite see it, but as I press enter, it's going back up to the top. And so I've got 4 lines, basically what's fitting in each of these segments right now. But of course I need to have it when I press enter, I'll just flip up to the next segment. It's that type of work I've got to do. So lots of assembly coding, but at least I've got I think a base that I can be working with as I do this. So exciting, a lot of work ahead of me, but this is stuff that I enjoy, good fun stuff. So thanks for watching, and I will share more as I have it.